Okay, Assalamualaikum, salam sejahtera. Hi, we are from Group D presenting our Matlab assignment. The signal given to us is stated below. As we can see, two different signals need to be designed and convoluted. We will explain each signal definition and how the convolution takes place. Okay, the plotting of the signal is shown below. The first signal, xt, is a rectangular pulse between the range of -2 and 2. For the next signal, rt, is piecewise linear, starting at 1 when t equal to 0 and decreasing to 0 when t equal to 1.
To find the convolution xt has to be times with rt. To obtain that, we will need to perform the integral function. So the integral function will be from negative infinity to infinity. Okay. So as we know, the rectangular pulse is between -2 and 2, and also the piecewise linear is starting at 1 when t is equals to 0, and also 0 at t is equals to 1. So we determine the ranges of integration by segment, where for t less than -2, for t is less than more than equals to -2 and less than equals to 2, and also for the segment t is more than 2. So for the plotting, after the integration, the plot shows the combined effect of the convolution over a wider range with the central region around t is equals to 0 showing the significant values where the signals overlap. This result illustrates the combined shape of the rectangular pulse xt and also the piecewise linear signal R3 through their convolution. For the Laplace transform, we will need to find the Laplace transform of the both signal xt and also rt first. Upon finding that, we multiply the Laplace transform to get the Laplace transform of yt, and then we find the inverse Laplace transform to get the yt in time domain. Then the time domain has been done in Matlab programming, shown in the next slide for the signal plotting.
Okay, next we go to MATLAB programming. Here we have a coding and then the graph we get from MATLAB. First we define the variable which is t for time domain and s for Laplace transform. And then we define the signal in time domain and then convert to Laplace transform. We have plot the graph -10 to 10. So the graph we get like similar like Chevy Chef graph. So the next slide will continue the explanation comparison with between time domain and Laplace transform.
Okay, comparison and analysis for time domain and Laplace transform convolution. Okay, for the time domain convolution, directly computes the convolution by sliding one signal over the other and integrating their product. Requires proper sampling and can introduce numerical errors due to discretization and finite precision. Okay, for Laplace transform convolution, transform the signal into the Laplace domain, multiplies via transforms, and then perform an inverse Laplace transform to obtain the result in the time domain. Theore- Theoretically, exact if the transform and inverse transform are compute accurate. Okay, for reason for differences, numerical errors, signal truncation, and then the last one is discretization. By carefully handling these factors and understanding the limitation of numerical methods, the differences between time domain and Laplace domain convolutions can be minimized, ensuring more accurate and reliable results. So that's all. Thank you.